we were talking about transformation of quadratic functions, and you want to graph quadratic functions in standard form and determine whether a graph has a minimum value or maximum value for the value of A. So minimum and maximum values, every quadratic function will have a minimum or maximum, and it will be located at the vertex. So in this case, we already calculated the line of symmetry for this graph, which was f of x. So we already calculated the line of symmetry was 3/4. So that's the x value of our vertex. And we know that this is going to have a minimum value because our A is 2, and that's positive. So our parabola is going to be concave up. So in the positive values, this is going to go to positive infinity. So the y is going to go to positive infinity, and the x is also going to go to positive infinity. And on this side, the graph is going to go to positive infinity in the y direction and negative infinity in the x direction. And that's going to help us out when we're talking about our domain and range. But in order to find out what our vertex is, we need to substitute in our x value back into the equation. So the function f of 3/4 is equal to 2 times 3/4 squared minus 3 times 3/4 minus 2. So we're going to substitute 3/4 in for the x, and that came from our axis of symmetry. And then we can go through and figure out what it is. We get 2 times 9 over 16 minus 3 times 3/4 minus 2. And that's going to be equal to 18 over 16. 9 times 2 is 18 over 16 minus 9 over 4 minus 2. We need to get a common denominator, so we can divide these both by 2 to reduce this fraction to get a common denominator there. And we can multiply these two by 2 to get a common denominator there. So we get 9 over 8 minus 18 over 8 minus 2. And so we end up with negative 3 and 1/8. So that ends up being our y coordinate. So our vertex here is 3/4 and negative 3 and 1/8. And then now we're looking at our domain. Our domain is all x values. All x values. So x values go across. And even though these arrows look like they're going vertically, we can see that as they go up, they're widening. And because it goes to positive infinity in the y direction, it's going to keep going up. It actually goes to positive infinity in that as well. And it's going to the left, which means it's going towards negative infinity, and it's going up, which is going to positive infinity in the y direction. So our domain for this one is going to go from negative infinity to positive infinity. Okay, and we use parentheses at both of those because they will never be included. For our range, as we're working with our range, we're going to start from the bottom and we're going to work our way to the top. So where do we start? Well, there's nothing here, nothing here, nothing here. And then right here at the very bottom, the y value is negative 3 1/8. So for our y values, that's going to be, that's going to be negative 3 1/8. And then in going up, as we go up, these arrows at the top mean that it's going to positive infinity. Positive infinity. Infinity is never included, but our negative 3 1/8 is included. So we use our bracket. And the last thing we got to look at is increasing and decreasing. As we go from left to right, we use our pencil and we trace the graph. So as we hit the graph, we start decreasing until we get to the vertex. So we decrease, and when we're talking about increasing or decreasing, we're talking about the domain or the x values. Okay. So we start at negative infinity. It's going to be decreasing, starting at negative infinity, all the way until we get to 3/4. Now, negative infinity is never included, and 3/4 is not included because the slope at the vertex is neither decreasing nor increasing. It's 0, so we don't include the 3/4. And then for increasing, it's going to start at 3/4 again, and it's going to go all the way it's going to keep going, increasing to positive infinity, and that is in the x direction. And again, infinity is not included, and the vertex is not included.